Hi, my name is Daniel Whitehead. I'm a principal solutions architect. Gabe, do you want to give yourself?
Yeah. Hello, everyone. My name is Gabriel Batista. I am also a solutions architect at AWS.
Cool. So Gabe and I primarily work with game studios. That's our remit at AWS. We're going to be talking to you today about building games with Unreal Engine and Horde in AWS. So first off, who here is using AWS? Just raise your hand. Cool. That's awesome. Thank you. Wanted to jump into this. We're going to be going through a couple of things here. So we're going to be looking at an overview of game development, and we're going to be talking about the unique challenges specific to game development, and then how there are specific things that happen that we're going to be talking about solutions that we can take a look at. So we have, and then we're going to be talking about Unreal Horde, and then Horde on AWS. So Horde is a software. What does that look like with infrastructure on AWS? How can we help accelerate your builds? Then we're going to be jumping into a project we've been working on called the Cloud Game Development Toolkit. And then from there, we're going to be talking about a little bit around what the future of that project is going to look like. Okay, I'm not going to lean back that far. So, software development. We write code, we build code, and then we ship code. This is a very traditional, this is a well-defined process. It's on the software world. We have, when you're using different tools such as Jenkins and GitHub Actions, there's a generally large community that is associated with this that are working on these things to make things easier. On the programming language side, we also have on like Node.js, we have Webpack on Java. We also have Maven and Gradle. So these are applications and softwares that are able to help you accelerate that. And this is a very well-defined process that is associated with just getting stuff through the door. However, this process does break down when it comes to games. Games are different, right? We deal with very large assets. And with that, so we have textures, we have animations, we also have character models and things like that that are all large in size. So this removes, we require larger storage and compute with this that allows us to be able to have a different build process that is more computationally expensive than the traditional software development pipeline. However, this is improving over time, and the community and the tools are progressively getting better. But these unique features have resulted in a gap between the traditional DevOps tools that software developers use and the ones that game developers are using. As we're going through this, we're going to talk about a couple of things. Perforce. Centralized version control. This is where most developers start when they're making their game. You have to have your team working off of the same code base because of the large object or the large 3D assets in there. We have a requirement for having the artist also working with us. So this is an industry standard that we leverage. Continuous integration and continuous deployment. This is the process of creating development tasks that do compilation, testing, and accelerate from source code to end executable. And then these are the build tools that are also corroborated with that. Last but not least, we're going to be talking about Unreal Build Graph. Build Graph is a script-based build automation system that features graph-like building blocks that are common in Unreal script projects. So this brings us to a standard development pipeline. Developers are working on code. They submit their code to version control. Version control then notifies the CI/CD system that, hey, there is a change. We need to do something about this. The CI/CD system is essentially the manager. The manager then notifies the people that are going to actually do the things, the CI/CD agents, that, hey, work needs to get done. So this is taking the source code, running it through all the things that we need to get an executable. The that's done, this then gets put back into version control, right? So we have a versioned executable that is corresponding with the run of that code at that time. From there, we then send that executable out to our agents and testers, play testers, possibly even shipping it, right? So this is the general overall pipeline for game dev. Now, we run into some challenges here. Our project sizes are big, right? Because of the inclusion of 3D assets, this means that when we have to hydrate a build, it takes a long time to get that onto block storage. We also have applications. The applications are super powerful, so we need to have more computationally intensive machines. We also have tool chains that are specific, right? You might have to build your editor, you might have to build your game, you might have to build a multiplayer server. All of those require a specific pipeline to be able to get that executable running. However, we do have solutions that that correspond with that, right? So because our large projects, if we have to access version control, we might be looking at caching, right? I can actually do a sync from Perforce to a mounted file system, so I don't have to hit my Perforce every single time I do a build. We also have specific hardware specialization, right? So cook jobs and compilation jobs, they require different kinds of hardware to optimize for that job. So we have the ability to split that out. Configuration as code. I can take my entire build pipeline from the beginning of my source control all the way to my executable, and I can have that scripted in a repeatable manner that I can do on this project or multiple projects. And on remote compilation, this is a mechanism that allows us to be able to take a build, distribute it across multiple machines, and then have those machines do a portion of the work in a faster time and at the same cost. This brings us to Unreal Engine Horde. Right? This is a CI/CD tool built specifically for game dev. This allows build graph scripts to be first-class citizens without the requirement of having to swap them to get them to function. It's built by Epic, and it solves many of the complexities of game development. The application itself is easy to manage and can be deployed in multiple ways, right? I can take the software, I can run it on compute, I can take a Docker container. There's multiple ways to do this as per many modern software. This directly integrates with AWS, and Epic actually runs this on AWS. Now, this brings us to Horde on AWS, right? So using the dynamic scaling features of Horde allows us to dedicate specialized hardware for cook and compilation jobs. Mountable storage allows us to cache assets from other build system tools. Separate storage, we separate storage from block storage volumes and mounted file storage to reduce the amount of data that has to go back, right? So if I had to hydrate my entire game on a block storage, that might take a long time for multiple build agents. If I put it on a mounted file system, I do that once and I can attach multiple things to that, right? We can scale these agents using a mix of hardware to optimize for artifact creation. And then we offload these artifacts to version control, or with one of the new announcements with GameLift streams, we can take that, upload that executable, and give our testers a stream of the executable that they can play immediately. So this is what Horde looks like on AWS. So we have our developers and our build machines that are sitting on the far left there. They're interacting with with Horde. The front end of that is going to be an application load balancer. We have a Horde service that's sitting on ECS Fargate container. Inside there, we also have an auto-scaling group with spot instances that can scale. So these are the dynamically scaling agents that they can either hit Helix Core or they can mount to the FSX NetApp on tap. That's the mounted file system that we're using to be able to offload having to go to source control. Horde itself is powered by Amazon Elasticache, which is a managed Redis service. And then we also have DocumentDB for the Mongo-compatible database layer. So I'm going to pass this off to Gabe, who's going to do a deeper dive into this.
Thanks, Daniel. So as you see here, this is the architecture for Unreal Horde. But let's be honest, none of you are here because you dreamt of building backends on AWS. You're here because you love building games. And it can be quite difficult for you to take an architecture like that and translate it into an effective workload and optimized workload, especially with a new tool that you may not be as familiar with. Because of that, the solutions architect team at AWS spent many, many hours going through documentation, reaching out to specialists, and shed many tears to be able to bring you all the Cloud Game Development Toolkit. So the Cloud Game Development Toolkit is a collection of infrastructure as code templates that allows you to quickly deploy common cloud game development workloads on AWS. All of the best practices, the optimizations are already baked in to Terraform templates that you can take and deploy quickly on AWS, and Horde is one of those. So to give you a quick walkthrough of the project itself, we have 3 key tenets that we followed as we were building out the project. The first is that we wanted to meet developers where they are. We know that you're already stretched thin building out your games. We don't want to introduce additional tools or additional frameworks to your day-to-day work. And because of that, we reached out to many studios to figure out what tools they are already using, which is why we chose to go with Terraform. Second, we wanted to codify best practices. We want studios to be able to come in and deploy these templates without needing to have a ton of knowledge around how it works, the AWS services, or even the workloads themselves. But at the same time, we wanted to provide studios with full control of what they are deploying. Because of that, we took all of the best practices and we made them available as defaults on the templates, but we gave all of the parameters so that once you have the template in your hands, you can go in and make whatever changes that you want to make. Diving quickly into the project structure, the project can be broken down into 3 pieces. At its most atomic level, we have assets. So assets are the pieces that we're going to use to be able to deploy the workloads themselves. These are things like runbooks or machine images that we ultimately use to be able to deploy some of the workloads that we have in the toolkit. A step above that, we have our modules. Now, these are the actual workloads that you're going to be deploying: Perforce, Horde, derived data caches, anything that's available in the toolkit itself as an individual workload. But we know that not every studio wants building blocks. Nobody wants Lego blocks. You want solutions. You want something that you can work with. And because of that, we created an additional level above that called samples. And these are entire infrastructures. It is a combination of the modules that we have available along with native AWS services to help you deploy entire infrastructures in one shot. So a build pipeline would be a great example, right? It's not just Horde, it's Perforce, it's Horde, it's distribution. We wanted to give you all an easy way to get that done. So diving into the Horde module itself, the first and most important thing is that we followed Epic Games' internal deployment suggestions when building out the toolkit. We took what they had already done for deploying Horde on AWS, and all we did was codify those best practices into these Terraform templates. We also provisioned DocumentDB and Elasticache servers for the Horde requirements of a MongoDB-compatible database and a Redis-compatible database. Now, like I mentioned before, we wanted to allow you all to retain full control, so you are able to pass in your own connection strings and provide your own databases if you prefer to do so. We also hosted the Horde server itself on Fargate. Again, we wanted to take as much management off of your backs, so we chose a serverless service, which is Fargate. It's AWS's serverless container service. To host Horde itself and allow you to not have to worry about maintaining these servers. It will scale out as needed, and if something goes wrong, it breaks down. Fargate will take care of shutting down the container and spinning up a new one. Diving into security, we created 2 separate load balancers for Horde, an internal and an external load balancer, to allow all of the communication, or as much of the communication as we can, to stay internal to AWS, and for us to be able to do TLS termination for all of the connections that are coming in. We also created an EC2 auto-scaling group for our build agents. This will allow the build farms, essentially, to be able to scale out dynamically based on your needs. As you're sending new build jobs to Horde, the build farm will scale out automatically to handle all of those jobs. And then when you're done, it will scale back in so that you can stop paying for those resources. No more idle compute sitting around costing you money. We also leveraged Systems Manager's State Manager to be able to run some Ansible playbooks to deploy these agents. As the agents are coming up, they need to register themselves with Horde itself. So as we spoke about before, we have some assets, some runbooks, specifically in this case, that we're using to have the agents automatically connect to Horde and have this entire build farm work seamlessly for you. And then finally, we provided some least privilege IAM roles and security groups so that you can feel comfortable deploying Horde for the first time and knowing that you're not accidentally opening up your entire infrastructure to the internet. And all of this allowed us to take this architecture that Daniel went through and convert it into this, just a few lines of code. So what you see here is the bare minimum that you need to get started with Horde on AWS. There are many more parameters available, but these are all defaulted, so it becomes easy for you to come in and just provide us with the bare minimum information that we need to be able to deploy Horde. Looking at the code that we have here, all we're saying is we're letting Terraform know where we want to deploy Horde itself, where we want to deploy the load balancers, which VPC we want to use, and then some security details like the specific certificate that we're going to use, the GitHub credentials that you need to be able to pull the container image from GitHub, and then finally the fully qualified domain name that we want to use to be able to host Horde itself. Okay, so the toolkit is much more than just Horde, right? So what else are we doing? We put a bunch of work into building out Perforce services or modules for Perforce services. At the moment, we have Perforce Helix Core, Helix Swarm, and Authentication Service, all built with best practices as you would expect for your version control workloads. We also have Packer templates for both Windows and Linux with all the build tools that you would expect to have for your build farm. So things like Visual Studio build tools, Octabuild, SC Cache, and P4 clients. Lastly, we took all of this work that we did and we made it available to you all through documentation. We wanted to make sure that you all had access to all of these architectures, to the details of why we made the decisions that we made, and how you can come in and customize the code that we made available. So talking about some of the new releases, this was actually just released yesterday. We finished a derived data cache module. This was actually created by Daniel Whitehead himself, along with another module, which is TeamCity, so that you now have options in terms of how you want to deploy your infrastructure, what your preferred tool is. And what's next? This project is completely open source. We're actively working on it, trying to add to what we have available to ultimately give you all options in terms of what it is that you want to deploy. So currently, we're looking at implementations for Unreal GameSync. TeamCity, like I said, was just released yesterday, so we can scratch that one off the list. Some guidances around building Windows platforms with Amazon Linux machines using Wine. This is a big one. Windows machines can be quite expensive, so being able to run these builds on Linux can make a huge difference at the end of the day when it comes to your builds. And then finally, we also want to look at other game engines, right? We know that not everybody is using Unreal today, so we want to make sure that we're addressing Unity workloads, Godot workloads, and any other engines that you're using today. But most importantly, we want you to tell us what you want to see next. So we ask that you take a look at the repository, you report bugs and request features. Ultimately, everything that we build is based on what our customers ask of us. We would love your help with extending the toolkit. We suggest a fork-first strategy for the toolkit, so copy the code over, make the changes that you need to make, customize it to your needs, and if you end up creating something cool, or if you disagree with our best practices, create a pull request, send that back to us so that we can ultimately share with the rest of the studios that are out there. And then lastly, and I would say most importantly, is that we want to create a community here. With all the studios that I've worked with over the past 3 years, I found from them that there is no secret to DevOps, right? None of the studios that I've spoken to had some kind of secret sauce on how to deploy these workloads. It's the same thing, and we just found that smaller studios are reinventing the wheel. Because of that, we created this repository as a place to aggregate all of that DevOps knowledge and then be able to share it with smaller studios so that they can get started quickly and create the next game that we all want to play. So to wrap things up, I just want to throw the QR code up here real quick. This is going to link you back to the toolkit itself, the repository. If you scroll down to the README notes, there is a link to our documentation. Please take a look. Let us know what you think. And thank you so much in advance for any contributions that you make. Thank you, everyone, for attending. And we have a few minutes left for Q&A. So any questions?
Cool. We explained that perfectly then.
Is this one?
Yeah.
Oh, yeah.
Okay.
I can hear you.
Hi. We just finished deploying Horde at our studio, and we have been thinking of moving to AWS, but right now we are like in a local instance, and one thing I did not see on the slides is Unreal's new version of TDC called Zen Server, right? How does this integrate with Zen Server, or does this make the use of Zen Server obsolete?
So no, it doesn't, right? So I think the way that I would characterize this project is what we are trying to do is find ways that we can help deliver that software in a way that also like we're within the licensing terms of what Unreal Epic expects, right? So in the case of Zen Server, like I know one of the things that we're talking about right now is a Packer script and possibly a module that actually correspond with that, because there's specific software that has to go on that, and then that's going to go in conjunction into a module. So that's something that I do know we're talking about, but it's not on the roadmap as of right now.
Got it. Thank you.
You guys, great talk. My question is, it might be a bit too technical, but you mentioned build graph as a first-class citizen. Does that mean you're writing your pipelines with the expanded build graph that Epic has, or like how are the pipelines created? Because I mean, some people use Jenkins or whatever else. So.
Yeah, so for the build graphs, Unreal Horde runs off of the build graph. So as you're building these pipelines, they are defined in Unreal build graphs. We came to find that a lot of studios were already using build graphs to create all of these builds. And Horde was just an easy way to be able to integrate back into the engine and make it easier for you to take that and be able to run those pipelines without having all of the additional CLI tooling and like additional scripts that you need to create to be able to run those build graphs.
So yeah, like if you're using it on like Jenkins or something else, like you have to use like either a Bash script or a Groovy script to run. That's not the case in Horde.
Yeah.
What about things that don't fit in the build graph and you want to
That's
be
a
part
good
of the
question. Come talk to us afterwards and we'll figure it out. So.
All right. Thank you.
Thank you.
Hi, thank you for the presentation. One quick question regarding Horde on AWS. What is the right procedure in terms of upgrading upgrading Horde, especially running like as a container workload?
Yeah, so as far as updating Horde, it's really going to come back down to Terraform itself. What we suggest is that you make all of the changes in Terraform so that you have that captured as infrastructure as code, and then you can redeploy Terraform to be able to upgrade all of the systems. Terraform is smart enough to know to only deploy the things that it needs to redeploy and keep the pieces that it doesn't. So hopefully it won't have an impact on your actual running build, but worst case scenario, you can just deploy a second copy of it and do kind of a blue-green deployment to switch over to the new version.
So just as a follow-up to that, is like because we're pulling container images, and so those that allows us. I mean, you can pin specifically to a specific image for as long as you want. Like I think, do you know in the modules, are we using latest or are we using a pinned version?
I believe we're using latest.
Yeah. So we have, because we're trying to provide the best out of the box. We're pinning to latest. So that means that whatever is the most current version is going to come down. When this is moving to production, that's like a recommendation that we would say pin that to a specific version. Use that until you want to upgrade, and then yeah.
Okay, cool. Thank you.
Thank you.
So as far as distribution goes, I don't know anything about Amazon Streams yet, but what about deploying to or sending builds for, to TestLite for Apple, or also deploying server-side code so that it deploys test builds of the server side of an engine, of your app, for example?
Sure. So there's a number of things that we can do with builds, right? Like I think I glossed over a little bit of when you're done, instead of having to go back to Perforce, you can have that go to S3, depending on if you want to put it into a CDN that's like contained to a specific IP, you can do that. So we have AWS CloudFront as our CDN that you can have like authorization access specifically to that build. We have both traditional and kind of like new ways of doing this. I think Game-Lift Streams is the one that we're excited to explore around, like, what if you don't have to ship an executable, right? To distribution, there's going to be APIs that you're going to have to hook in that are going to send that build over there, but that's a very common procedure that customers are doing right now. Yeah. Anything I missed?
No. Yeah, so for the server side, there are multiple options. What we tend to see with our customers, if is if we're talking about backend, things like leaderboards and chat, we see container services being used a lot. So things like Elastic Container Service, ECS, or Elastic Kubernetes Service, EKS. And then as far as multiplayer servers, we have Amazon GameLift Streams to help you deploy your multiplayer servers, take care of any kind of scaling, and even help you find the server that is closest to your players to provide them with the best possible experience. If you haven't had the chance to, come stop at our booth on the expo floor. We actually have a demo that speaks directly to that, and it shows you how we host each of the individual pieces, the backend, the game servers, and then the game client itself, using the 3 services we talked about, container services, GameLift servers, and then GameLift streams to ultimately be able to stream that client to the play testers without ever having to send the executables over.
There's a lot of ways to solve that problem, right? Like I think that's like the big thing is, again, come talk to us at our booth. We have a lot of different ways of doing this depending on what your specific circumstances in your studio are. Yep. All right, looks like there's no more questions, so awesome. Thank you very much for coming to our talk.
Thanks, everyone.